If you listened carefully to the previous lectures, you'll notice that from here on, there will be a lot of repeated content, so we'll proceed with a review-like approach. This question asks you to choose the option related to the decrease in intensity as the ultrasound beam is attenuated while passing through. The correct answer can be considered to include all of options A through D, so you can select option D. Next, let's move on and look at problem number 82. This problem also asks about a basic concept. This question is asking about the relationship between frequency and absorption. As the frequency increases, attenuation also increases significantly, so absorption rises as well, showing a direct correlation between the two. The correct answer is option B. For your reference, if the frequency doubles, absorption also doubles, indicating a proportional relationship between them. Moving on, let's look at question number 83. If you look at the question, it's asking about related terminology. For these kinds of questions, it's helpful to remember the sentence itself as you solve the problem. The term that refers to the decrease in intensity, meaning the reduction in intensity as the ultrasound beam passes through, is attenuation. Once again, for this type of question, it's important to remember both this expression and the sentence here that explains attenuation. Next, let's look at question number 84 below. Similarly, since this is a question asking about terminology, let's go straight to the answer. In the question, the term non-specular reflection is mentioned. This refers to reflection that does not have a specific direction. The answer is related to the term scattering found in option D, so you can summarize it that way. For patterns like this that ask about terminology, since they're simply asking for definitions, you can go straight to the answer. Just make sure to review the sentence as well. Moving on, let's look at question number 85. If you look at the question, it asks you to choose the option that shows the strongest reflection signal during an abdominal ultrasound exam. What this sentence means is that a strong reflection can also be described as a large difference in acoustic impedance values. Therefore, you should choose the option with the greatest difference in acoustic impedance. The correct answer would be option C. The rest can be considered similar soft tissues such as liver and bowel gas or air. Since these two have a large difference in acoustic impedance, they can be observed as strong signals on ultrasound. Now, let's move on and look at question number 86. If you look at the main text, it explains that it has listed the physical phenomena that can appear during an abdominal ultrasound examination. This question asks you to find which of the phenomena listed here is not related to reflection in a different direction. In the case of options A and B, as well as C and D, the ultrasound beam either returns directly or, in the case of scattering, spreads out in multiple directions without any specific directionality. In this way, changes in the directionality of the ultrasound beam can be seen in options A, B, C, and D. On the other hand, in the case of option D, absorption can be explained as a conversion of energy into heat. Once again, what the question is asking is to find the one that does not involve a change in directionality. In the case of option D, it does not manifest as a change in directionality, but rather as a phenomenon where it is converted into heat. Please note this difference as you review. Next, let's move on and look at question number 87. Since this is something I've already explained in detail earlier, let's go ahead and check the answer right away. You can select option A as the correct answer. Let's look at question number 88, which is right below. In the case of this question, since it relates to ultrasound artifacts and image distortions, I'll explain the details when we move on to the section about artifacts. Here, I'll just briefly go over the basic concept. Now, the content described in the question is that during an ultrasound examination, for example, if there is a liver, it says that there is a large lipoma inside. The fact that they specifically mention fat as a clue can be considered an important keyword. Generally, the reference value for soft tissue in ultrasound is set at 1540. Unlike other areas, a lipoma is mostly composed of fat, so it is set to a slower speed than the reference value of about 1460. So, when we look at it in comparison to the area where the ultrasound beam is able to pass through the tissue normally, the specific part where it passes through fat travels at a significantly slower speed of sound than all of those other areas. Because it takes longer for the signal to travel to and from along the same axis, if the image is normally supposed to be formed at a certain point, this delay can create an artifact where the image appears to be formed farther away than it actually is. To summarize once again, the key point addressed in this question is that differences in the speed of sound through various tissues can create image artifacts. Please make sure to keep this in mind. Based on the above content, let's take another look at the main question. To interpret the question again, it describes a large mass, most of which is composed of fat. Yes, the fact that this was specifically mentioned can be seen as evidence that it is an important clue. Because these tissues have a slower speed compared to others, artifacts that are not properly represented along the same axis can be created. So, you should select answer choice B as the correct answer. Just be aware that such issues exist, and we will cover more detailed information in depth in the artifact section. Moving on, let's look at question number 89. Since this question is also based on fundamental concepts, let's go straight to finding the correct answer. This question asks you to identify the causes that can lead to refraction. I've emphasized these two factors several times before. The correct answer is choice C. Just make sure to check the difference in insertion angle and propagation speed in the options. Next, let's move on to question number 90. Looking at the question, it explains that during an ultrasound examination, a transducer is being used at omega hertz within a wide bandwidth. Clinically speaking, for example, it's very rare for a convex probe to be strictly limited to omega hertz. Usually we use probes with a wide bandwidth, such as from 3 to 5 or 5 to 7 megahertz. Now, this question asks you to choose the correct answer when using such a probe and performing a reverse scan. In the end, using a probe with a wide range means that you can appropriately adjust it depending on the depth. The correct answer would be option A. Whenever you observe that attenuation increases due to a higher frequency, you can choose to lower the frequency to obtain a significantly better and clearer image. And this is precisely the reason why a wide bandwidth is used within these types of systems to ensure the highest quality. To summarize once again, in general clinical practice, instead of using a probe with a single frequency, various types of probes are used, such as those that can switch between 3 to 5 megahertz, so that changes can be applied according to the appropriate depth. So, through these questions, you just need to check your understanding of these concepts. With this, we've solved up to question 90.